All right, hello everybody. My name is Ali Hosseini. This is Sage LaTorra. We're both visiting Krakow from the U.S. Seattle. I'm visiting from Mountain View, and beautiful city. And thank you for welcoming us to this beautiful venue. So I'm going to be talking about how we transitioned to using Jetpack Compose in Google Messages. Google Messages is the app for sending SMS and RCS messages on Android. And then Sage will be following that up with a discussion about how we're adapting our testing for that. So Jetpack Compose, just to get started, you probably have heard of it by now. It's been out for a few years now, and it's gradually taking over in terms of the way to do UI in Android. So rather than doing Android views with XML or doing it in code, we're switching over to doing reactive UIs through Jetpack Compose. Jetpack Compose has a lot of benefits. One of the biggest benefits is it's super efficient to do recomposition. And what that means is if something in the UI changes, we only need to re-render that particular part of the UI and don't have to re-render the entire screen, which is what we would have done with Android views. And it also enables reactive to be super efficient as a result, because if some particular part of the data changes, we reactively tell the UI that this part of it changed, and then the UI redraws that particular part of it. And then it's also very efficient in terms of composing elements. So if you've done Android views before, you know that if you have a big nested hierarchy, lots of elements, it is not good for performance. It ends up slowing things down. There's a lot of work just in loading the XML files and then even in the rendering. And Jetpack Compose solves that to a large extent, allows you to have really deeply nested hierarchies and many components without worrying about the performance implication of that. You can kind of see on the left there, I don't know how visible it is here, but this is basically what composable, which is a single unit of a widget or something in the UI would look like. So it's just a function with functional input, and then it is expected to output some UI as a result. So what that lets you do is create these kind of view hierarchies, and so you'll see what we kind of have in Google Messages, where at the very top we have the conversation screen, which is made up of a top bar and a message list and an input row. And each of those is made up of even more components. So the top bar has the call button, the search button, and then the message list has a column which has a massive number of messages, each of which is, maybe a text block or an image, a reaction, or whatever else. So lots of components, and they can be kind of put together like Lego pieces, and we can do that efficiently. And then it also enables us to do this critical thing over here, which is having a unidirectional data flow. So data kind of enters here and then bubbles down through the hierarchy. So that's Jetpack Compose in general, which is great, but it's really only a solution for the view. We needed to take that and then figure out the best way to get it integrated into the rest of our application, from loading data to implementing our business logic to then eventually getting to the view. And so that's where MVVM comes in. This is a general overview of what MVVM is. I'm sure you've mostly all heard of MVVM, but it is the kind of the most popular right now pattern for UI architecture. It's made of three pieces: the model, the view model, and the view. And each of these is, you can think of it as a layer, and each layer basically only knows about the layer below it. So in the view layer, you have all the Jetpack Compose, in our case, view objects. it's responsible for only one thing, and that's rendering and responding to input. So when I click, something should happen. That's in the view. The next layer, you got the view model, which is the piece that it defines what the application can do at a given moment, right? So it's what are the actions that I'm allowed to take, and what is the data that I can present. So if I'm presenting the conversation screen, for example, the data that I can present is the list of messages, and then for each of the messages, there's data that those have. And then there's also actions that I can take, like sending a message or starring a message or whatever it is. And then at the model layer, we have all of our business logic and data access there. So none of the business logic ends up in the view model and never in the view. And data access also does not end up in the view model or the view. All of that ends up with what you kind of see in this diagram over here. And so the view takes an action on the view model, which then ends up invoking something on the model to transform data, for example, to send a message or to star a message. And that results in an event getting published upwards to the view model, which observes it, and then it exposes new data for the view to draw. And so data flow basically kind of goes up from the model, but the dependencies go downwards. So the view only knows about the view model, and the view model only knows about the model in this general MVVM concept. This is something I basically went over right now. I'm going to skip that. The unidirectional data flow piece is kind of important. To achieve unidirectional data flow, we basically have immutable data, and then modifications, mutations are done through the actions and the invocations that we do on the immutable, sorry, not on the immutable data, but on the things that expose the immutable data. Yeah. So how did we apply that over to messages? This is basically it. So we got the three layers that I talked about, the view model, and the model. At the very bottom of the model, we have MAPI, which I'll explain in a minute. But it basically encompasses all of our business logic in terms of how to send a message, how to star stuff, how to send reactions, and all that stuff. At the view model layer, we have these two concepts called the UI adapter and UI data, and I'll be explaining those as well. And then on top of that, we have the regular fragment, which has a composable at the root and then many composables under, if you remember our viewer hierarchy from before. And then we also have a series of components that I'm going to get into at the very end, which is our component library. So MAPI, what is MAPI? So MAPI stands for Messages API. It's basically our new model layer for messages. In the past, we had a very different approach to how we access data. Very often, fragments would actually call into the database directly and wait for data. So completely new model. Primarily uses the repository pattern. So you have a bunch of repositories. You have a conversation repository. We have a message repository, recipient repository, etc. And these are responsible for fetching data and caching data in-memory caching of data. And then there's obviously persistence that happens kind of a little below that. So MAPI actually encompasses communication with the database as well. And the database is the thing that obviously persists the data. So that replaces our old database code. As I mentioned before, we had like a lot of raw database access practically sprinkled through our fragments. We've gone away from that, and we now have a clean abstraction that allows us to code against an abstraction and also, if needed, switch out that the implementation of the abstraction for whatever makes sense for a given scenario. So on wearables, we'll have a different implementation. On phones, we'll have a different implementation. And actually on tablets, we have yet another implementation. So the next little bit in our hierarchy, or our layers over here, was the UI data dimension. So the UI data is the immutable data type. It is the thing that represents information about a thing. So if we think about a single message, you will have a message UI data, and it'll include things like what the text of the message is, whether it's been favorited, whatever else may pertain to that particular message, the time it was sent at. And then, yeah, so that's the data for the view to render. It never contains any styling because we're at the view model layer. We're not at the view layer, so there's no styling information there. And then it also holds the callbacks for the actions. So it exposes all the actions that you can do. So if you're talking about a message, again, in that example, it might be that long pressing stars the message. Well, there will be an action on the message UI data, which is star message. And that's literally the name, star message. And then the view gets to decide, okay, how am I going to actually invoke that method? Well, it turns out when I long press it, I'm going to be calling that UI data method to star the message. So all of that needs to actually be generated from somewhere, and that's where the UI adapters come into the picture. So the UI adapters basically go and grab data from Mappy. So they'll get the list of messages, for example, for a given conversation. And then they'll transform that data that they got from the database, from Mappy's abstraction, into UI data objects. We never ever pass data model objects up to the view. The view never sees those. We always transform them into a UI data. And the transformations that might take place, a simple one is date transformations, right? The way we serialize dates is not the way we want to present them to users. We want to localize it. We want to, maybe shorten the date or the format or whatever it is. And that's something that we would do in the UI adapter for the UI data. Yeah, and it's also structured in a hierarchy very similar to the view hierarchy. So like the conversation that I mentioned at the top, which had the top bar and the conversation lists and then the list of messages, we have a conversation UI adapter at the top, and then we have a message list adapter, and then we have message adapters. So each kind of node in the view usually has a corollary in the UI adapter layer. Not always, because some concepts are just view concepts, and it doesn't make sense to have a UI adapter at all for those. Yeah, and then so through that hierarchy, we basically call create data on the root object, and that basically starts calling all of its children, calling create data on that, and ending up with a single UI data that we then pass over to the view. And that becomes our entry point into, the view hierarchy here. So we send in a UI data into here, and then each of these things interprets the UI data as appropriate for the view that's going to show it. The last little bit here is our communications components library. So this is really just ABC's design system. It's an implementation of that design system. ABC's Android Business Communications. Sorry, I should have mentioned that. Yeah, and then so basically an implementation of that design system. It has all the common components that you would expect. So like if message bubble is an example of them. We're not the only thing that uses a message bubble. As it turns out, there are multiple communications apps in Google. And so that's the opportunity to reuse those components for different apps. And so these components are all very dumb components, though. So they have no knowledge of the actual application that they belong to or they're being used in. And so, again, very basic. It is a bubble. It has the ability to be styled however the consuming app wants. So, for example, messages for the bubble will style it in the green color or the blue color with the angle the way we want it. It makes no assumptions about the underlying technology either. There are no uses. There's no usage of flows. There's no messages specific stuff in there. It's all very agnostic of the underlying app. and no flow code collection. So that's pretty much it for me. I'm going to hand it over to Sage, and he'll go over testing.
Cool, thank you. So my name's Sage LaTorra. I lead the ABC EIO team, which we've already gotten into our wonderful world of jargon, so I'll just go ahead and expand that out. ABC is our Android and Business Communication team, and EIO is Engineering, Infrastructure, and Operations. So this, you may have also heard the term InchProd, which we use as well. So this is a little bit like testing at some other companies, but really with a focus on things that accelerate our developers and make their lives easier. And in this case, we were doing a massive migration, basically ripping out part of our app and replacing it with an entirely different implementation that was different, but functionally the same. So we needed to find ways to enable our developers to move quickly with this, while also supporting the level of quality that our users and our partners need. So first of all, a little bit about testing at Google. So my team is here to make our code easy to change, hard to break, and efficient to ship. If you write the code, you write the test. So we operate a little differently than test teams at some other companies. In general, we are not writing the test for somebody else's code. We are going and talking with folks like Ollie about what changes are happening and making sure that our infrastructure enables us to write efficient tests there. Sometimes we'll do a proof of concept test. In some cases, we do end up owning some tests for specialized areas within the app. But in general, if you write the code, you write the test for it. And you probably end up writing more than one test. We really emphasize the idea of a testing pyramid. Lots of unit tests. The smaller your test, the more reliable it is, the easier it is to write, but the less fidelity in general you have to the real world. Mini integration tests. This is kind of the middle area of the pyramid. And in a lot of places that I've worked, this is the area that's most lacking. We talk about the test pyramid as kind of an idealized form. A lot of places end up with the test barbell, kind of like a lot of weight on one side, a lot of weight on the other, and this middle area is kind of not filled in. Especially on messages, I've found this middle area to be where I think we've gotten some of the best return on investment. And then fewer end-to-end tests. For us, this generally means real device tests. Real device tests are inherently flaky. There is always some downside to working with real devices. There's also a ton of upside, and that's the user experience your users are going to get. So basically, the easy rubric here, the larger the test, the fewer of them we want. If you're the average developer working on Android messages, we want you writing unit tests all the time, part of your basic flow. Integration tests as your pieces start touching new things. Maybe a few kind of larger integration tests as you hit some different product flows. And then you're probably not going to have to touch the end-to-end tests all that much, because generally we want those to only be for the most core flows of the app. So with all that in mind, what were we going to do about this Jetpack Compose migration? Our first problem is that we now have two implementations of the same UI claiming to do basically the same thing. The old UI has tests. The new UI does not, but it's conceptually the same UI. So the really easy thing here would have been if all our tests magically ran against the new UI. Unfortunately, you don't get that for free because our tests were written for a specific implementation of the UI, and we don't have a kind of generalized, machine vision model here that's picking out the send button. We're using details of the send button to find the send button on the screen. Well, those details are about to change out from underneath us. And importantly, for a migration as large as this, we're going to have both sets of code live for quite a while. In fact, I just saw an email that we finally deleted the old code, and this was considerably after this migration finished. So we needed to be able to write tests. We need to be able to our developers to write tests that could cover both of these UIs efficiently at the same time and keep shipping efficiently while doing both. Our second problem is that even within the old tests, there were many ways of doing the same thing. So if all of our old tests had used the same way to send a message, for example, well, then we could go into one place and change all of the tests all at once. We didn't have that. Many of the tests were finding their own way to do things, which meant that A, they could all break in different ways. And then on top of that, we couldn't find one singular place to update each piece of logic. So to adapt to these problems, we started abstracting out our tests. Instead of a single implementation in each test for each flow, we started building out, similar to some of the abstractions Ollie showed you, view controllers that match the things on the screen and provide interface level definitions of how you might interact with a given screen. We can then provide implementations of that can run at different levels of our testing pyramid, whether that's a roboelectric unit test, an espresso-based emulator test, or UI automator-based real device tests, and enable our developers to write a test that defines a user flow and then think about that flow at different levels. That's not always going to be the case. In unit tests, for example, sometimes you really want you always really want some function level coverage that doesn't really match up to an overall user flow. It'd be overkill to test your method for verifying the length of a message by sending a message every time. But this does enable us, anytime we're starting to talk about user flows, to run that user flow in different places. And we could also branch out for different implementations of the UI underneath and select them dynamically when needed. So here's an example. The code in the middle is not real because I didn't want to figure out what code I could show to people, but the screenshots are, and they actually come from our tests. So the way our screenshot verification works, our code repository has screenshots built in. These are things a user could have gone and gotten to, but these are actually generated by our tests. On the left is the old implementation, which you can see had some problems with flowing on smaller screens. And then on the right is the new Jetpack Compose implementation, which you can see is doing conceptually the same things, but gets into a slightly different state and has slightly different UI definitions, a few different buttons in different places. But from a user perspective, this looked like a fairly small update. From a developer perspective, these are massively different implementations. But now we could have one test that could generate both of these and maintain both of these. And so if you as a developer go in there and change just one implementation, you don't have to change the test necessarily. You might approve the new UI master image. So the outcome of this, our developers have reusable recipes for common actions. This was actually a win regardless of whether we were replacing our UI or not, because now if we need to, say, make another big change to our UI, we don't have to bother updating, say, hundreds of tests for where the send button is or how to find the send button. Now they all use the same way to find the send button, and we say, update that one spot, and we're done. The same test logic can be run at multiple scopes and against multiple environments. So these are write once tests. You think about the user flow, and then you decide which environments it makes sense to run in, and you're done. And then our tests are more closely related to the actions and intents, not implementations, which is great for this level of testing. There is a level of testing, those unit test levels, where it really is about the implementation. You don't want to abstract out into the user flow, but ultimately, the user flow is what the user sees. And so by working more conceptually in our tests now reflect flows through the app that the user might take. Great, and that is my last slide. Thank you so much for having us out here. This is my first time in Poland. I'm here both to do this and because I am building a team here. So if any of this sounded interesting, Google has many open roles, including some on my team. And we are really happy to be out here and to chat with you all after the I/O keynote.
We have 5 minutes for questions. Do you have any questions, guys?
Or even chat with you right now before the I/O keynote. Yeah.
Thank you for presentation. Right now, my team is working on migrating from old, good XML, something like that, to Compose. And that topic about testing and even like UI level, it's so important for us. Of course, it's for developers. We need to build tests, etc., etc. But we have PMs who are asking us, "Hey, are we going to finish that by the end of this month?" How you deal with the PMs, managers, and whoever? Like, who wants to, hey, can you please write those tests maybe later after the feature is finished? Like, any tips?
I deal with a manager by being one. I didn't do any of this work that was here. This was my team. So I should actually say I wish they were here to present on this, but I'm the one to talk about it. No, the important thing there that I tend to emphasize in this, it's kind of a truism, but speed, ease, and quality, like choose two. Do you want to ship the right thing? Do you want to ship it tomorrow? And do you not want to burn out your team? Some triangulation of those three goals. And I find PMs in particular tend to, this is kind of their bread and butter, is planning things out. And when you think about, do you want it right? And then do you want it to be right in the future? Writing a test for what we're shipping tomorrow is sometimes feels like overkill. I've already made sure it works right now. Why do I need to do it again? But presumably we're going to keep on modifying that code. And the test is your insurance that you can keep on modifying that code and not break your user experiences. Anything you want to?
I mean, the biggest thing is convincing them that by having that coverage, they can move quickly afterwards. So like the next change they're gonna inevitably want, if they want that quickly, they need to give some of that time now so that we can then move quickly in the future.
Thanks. I will try to speak with my PMs. I hope I will work there. Okay, I have a next question about that. Like, I never seen such, let's say, way of creating tests, like to separate UI from actual, like, implementation of UI to implement the test. But this idea is so, like, it feels so natural and understandable. But how much time it takes to teach newcomers to like get into that way of coding, because every developer, every newcomer has its own his own style of coding, etc. But this is something interesting, like, yeah.
Generally, I've found the best answer there is to make it easier to do it the right way. This is an upside to how Google approaches things like this with dedicated teams like mine that are responsible for making it easy. But then for somebody who is writing the test, we've gone in and done the work to make sure that these controllers are in place for the most part. They've continued to be expanded by people working on the features. And so if you show up to write a test and it's either, oh gosh, I've got to figure out how to find, how to create a new conversation again, or there is a view abstraction that says, hey, I'm on this screen, I would like to start a conversation with this identifier. That's now the easy option, and it's the one that's going to be maintained into the future.
I think it actually allows you to move a lot quicker when you're learning, because the alternative is you have to figure out every little piece of the way along the way. And that's what we had and have still in some places. And people really struggle with that. And when you have something that's just kind of, you pick it off the shelf and say, yes, I want to do this thing, great, and it does it for you, it's so much easier, right? So.
One last question. Okay.
Hello, thank you for the conversations. I have one question about if you think, I don't know if you use it, but screenshot testing in your project, I don't know if you use it, so that's why I'm asking for it. And if you think it's important or not in this.
Yeah, actually, a lot of our testing is actually screenshot testing. In fact, Sage's slides from earlier show some of that. We use screenshot testing a lot, and it's valuable. It caches issues. There are also times where it just misses issues completely, or it fires for no reason. That's just the reality of screenshot testing. But overall, it's been net positive, I think.
Okay.
And I'll just expand on that. Part of what I think makes screenshot-based testing valuable for us, we leverage a lot of tools that were developed within Google at Google scale, so we don't have to, for example, write comparators with different logic behind them, and the review process. Like if you updated this implementation so it was going to be different, your failing test would come with a link to an internal site where you can view side by side the before after with the diff highlighted, and with one click accept the new golden image if that is what you intended to do. So in general, like I'm against change detector tests test that's going to fail no matter what changes in the code. But the one time where I'll take a change detector test is in the UI, because to me, this is a way for the developer to, in their change list, assert that they know that they're making a change to the UI. So if the golden images that are checked in change during the code review process, the reviewer can look at that and say, wait a second, this new UI you checked in looks horrible. Why are you doing this? Or it looks like, this is great, LGTM. Looks good to me. Sorry, that's our internal submit button. In general, I'm a fan of these, but part of that comes with the ability to scale it thanks to common tooling. I think if I were starting 100% from scratch, knowing what I know now, I'd look for some external product that did some of this comparison piece so I didn't have to write it from scratch. And if the only option was to write it from scratch, I wouldn't be quite as sold on UI tests.
Okay.
Or screenshot tests, sorry. Always have UI tests, but screenshot tests.
Okay, thank you so much.